Hi, my name is Marisa and I'll be doing the 2012 FRQ number 4. In the description, I have put a link to other problems like these if you want more practice. So let's read the problem. It says, the function f is defined by f of x equals the square root of 25 minus x squared for the domain of x is in between -5 and 5. Part A says find the derivative of f of x. So in order to do that, I suggest changing this square root into a power of 1/2 so that you can do the power rule. Doing the power rule says that you're bringing the 1/2 to the front and then you're subtracting the power of 1/2 minus, you subtract 1 from 1/2, which is just -1/2, but then you still have an x squared in the 25 minus x squared. So you are going to need to use the chain rule and multiply by a -2x, which is the derivative of -x squared. Simplifying that, you will get 1/2 times -2x, which just simplifies down to -x all over the square root of 25 minus x squared, since this is a power of -1/2, which brings it to the bottom. And this is your derivative between -5 and 5. Part B says write an equation for the line tangent to the graph of f at x equals -3. So we are trying to find an equation, which means we need a point and a slope. So in order to find the slope of the tangent line, we are going to plug -3, which is given as x equals -3 in the problem, into the derivative. So plugging that in, you will get 3 all over the square root of 25 minus -3 squared, which is just 3 to the square root of the 3 over the square root of 16, which is just 3/4. But now you need the y value to the point of x equals -3. To find that, you will plug the -3 into the original equation, which is given at the top as f of x equals the square root of 25 minus x squared. Plugging that in, you get that f of -3 is 4. So you're going to do y minus y1 equals m times x minus x1. So y minus 4, which is the y value that we found here, equals 3/4, which is the slope of the tangent line found by doing the derivative of f of -3, times x minus 3, which was x plus 3, which was given up there. X minus -3, which gives you x plus 3. And this gives you y equals 3/4 times x plus 3 plus 4. Part C says, let g be the function defined by g of x equals f of x for the for the x values between -3 and -5, and x plus 7 for the x values between -3 and 5. So this is a piecewise function. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. So, to find continuity for a piecewise function, you're going to check if it's continuity. You are going to check to make sure the left and right limits are equal. So in order to do that, you're going to set the limit of x equals -3 from the negative direction, which includes values such as -3.001 of g of x equals the limit of as x approaches -3 from the negative direction of f of x, because that's what's given in the piecewise function here, is equal to the limit of as x approaches of -3 from the negative direction of what f of x actually stands for, which is root 25 minus x squared. So if you plug in all those values, the limit is equal to 4. And then you're going to do it from the right side. The limit from the right side is the limit of as x approaches -3 from the right, or the positive direction, which includes values such as -2.999, -2.998, etc., equals the limit as x approaches -3 from the positive direction of x plus 7, which is given in the piecewise function, equals to 4 as well when you plug in those values. So, since g of -3 is f of negative 3, which is given up here, equals to 4, and the limit of x approaches negative 3 of g of x is equal to g of negative 3, then therefore g is continuous at x equals negative 3. So now you've solved A, B, and C. Now you just have D. Find the value of the antiderivative between with the bounds being 0 and 5 of x times root 25 minus x squared dx. So we are going to find the antiderivative. Since this value is going to be very difficult to find the antiderivative, we're going to use u substitution. So picking your u is really is one of the hardest parts. So what you're going to do is, sometimes it's a trial and error kind of thing, but the successful u substitution is making u equal to 25 minus x squared. Now du for that is negative 2x dx. And that is just by taking the derivative of the negative x squared, since the 25 just goes away when you're finding the derivative. So the antiderivative with the bounds being 0 and 5 of x times root 25 minus x squared dx is equal to negative 1/2 times you changing the bounds of 0 to 25 of root u du. So root of this u times du. And what you need to do to account for the negative 2x dx is you're going to switch this and put it on the outside of the antiderivative as a negative 1/2. So see this traveling. There you go. And then finding that antiderivative is just negative 1/2 times 2/3 u to the 3/2, which you're just changing this root du into a power rule. So you're doing a 1/2, and then finding the antiderivative, you add 1 and then divide by the new power. So that gives you 2/3 u, the 3/2, as if u is 0 and u is 25. And plugging that in is just negative 1/3 multiplied by 0 minus 125, because you'll plug in 0 to this whole thing, and then plug in, and then you're subtracting, plugging in 25 for u. And that's what gets you 0 minus 125. And the answer to all that is 125 over 3. And that is all. Yeah, thank you.